this is a video on perimeter and area. This top one here, it says the following rectangles are similar. If the area of the smaller rectangle is 20 square units, what is the area of the larger rectangle? Well, one of the things, so the perimeter is a linear measurement and area is in square units. And so if you can determine what the linear ratio is, then you can just square it to get the ratio of the areas. And once you've got that ratio, then you can figure this out without too much trouble. So 5 to 15 is the ratio of this smaller side to this larger side in the smaller rectangle to the larger rectangle. And so they're proportional. So if I say, well, 5 is to 15, if you know how to simplify fractions, you can see that that one's not too hard. And if you don't, you can use your calculator, and it looks like this. So I take 5 and I divide by 15, and it gives me this decimal. And then if I hit math, enter, and that's converting to a fraction, enter again, it just gives it back to me in simplified form. And so 5/15 is the same as 1 to 3. And that means that the perimeter is in the ratio of 1 to 3. But that means that the area will be in the ratio of 1 to 9. And so if the area of the smaller rectangle is 20, we don't know what the area of the larger rectangle, let's go ahead and call it A for area. Then A times, and in a true proportion, the cross products are equal. So this times this will be equal. And so I can say 1 times A, which would just be A, is equal to 9 times 20, which would be 180. And so the area would be 180 square units. If they had told us that it was yards, if this was meters, then it would be meters squared. If it's inches, then it'd be inches squared. If it was centimeters, then it'd be centimeters squared with the area. It's just square units. And so that's your answer for this one. Proficient here, it says the calculate the area and the perimeter of the following shape. Now on this one, we don't know how long these are, but we can figure out what they are. And so I'm going to say, hey, if this is a square, that these are perpendicular to each other, then I'm going to say if this is 2 inches here, then this part between these two lines is 2 inches. And that means that we have to kind of make some assumptions here, but let's assume that this angle and this angle are the same. That would mean that these side lengths are the same. So this would be 1 inch, and this would be 1 inch here as well. So you've got your 1 plus your 1 plus your 2 plus your 1 is your 4. That is the whole thing. Let's bring this down here so you can see that a little better. And so 4 is all the way here across. This is 4 inches. And that's the same as 1 plus 2 plus 1. So this is 2 inches and this is 1 inch. So I can use the Pythagorean theorem. 1 squared plus 2 squared equals, let's call this x, equals x squared. 1 plus 4 equals x squared. 5 equals x squared, and then taking the square root of both sides would give us that x equals the square root of 5, which is an irrational number. So again, if our assumption was correct, this is the square root of 5, then this is also the square root of 5. And then we can just add up. So I've got 4 plus square root of 5 plus the square root of 5 would be 2 times the square root of 5 plus, let's see here, here's my 4, which is all the way across here. And then here's my top, there's 2, and that's all 4 of the sides. This is square root of 5, this is square root of 5, and so the perimeter, just all of those added together. And here's my 2 square root of 5, here is my 4, and then here is my 2. And because these are whole numbers, I can say 4 plus 2 would be 6 plus 2 root 5, and that 6 plus 2 root 5 would be the exact answer. If we want an approximation, we can plug that into our calculator. 6 plus 2 root 5, and that would give us approximately 10.47. So 10.47. Again, depending on how your teacher wants you to answer, it could be either one of those. All right, the area. There is a formula for the area of this figure, which is called a trapezoid. But we can also just know, like, hey, I can get the area of this, which is 2 times 2. So this is 4 square inches in, let's cut the color out of these. Um, 4 square inches is this right here. We already know that area. And so that's 4 square inches. And we're going to add that to whatever this is. Now, if I took 1 times the 2, that'll give me 2. But that would be if I had a whole rectangle of that same dimension. We only have half of that because it's a triangle. So we take 1 times 2, 1 times 2, and then we divide that by 2. And so this is the equivalent of 1 square inch, because the 2's canceled. But since I have 2 of them, times 2, then this is going to be plus 2 square inches. And so the area of this is 6 square inches. All right, moving right along here. Now, here it says the following triangles are similar. Find the ratio of the perimeters from large to small and the ratio of the areas. So if we're going from large to small, I can get the area of the perimeters without even finding their perimeters, because each of their sides, they're similar. Each of their sides will be in the same ratio as their perimeters. So 16 to 4 is the same as 4 to 1. So the ratio of the perimeters, 4 to 1. And since the area is the square of that, it is just 4 squared, 16, to 1 squared, 1. And that's it. You got this. Study hard. That's the end of this section. Have a great time. Study, prepare. You'll do just great. Have a good day.